Today we will learn the chapter Indeterminate Form. What do you mean by this chapter? First I will tell you. In the previous chapter you have already learned about the limits, continuity, differentiations. Okay students? And today I am going to tell you about the limit and what you have learned in the previous chapter, but in this chapter the same point we will discuss using the L'Hospital's rule. Okay, student, first listen here. As you know that fx upon gx, x tends towards 0 or x tends towards a, any limit that it is a, and when you solve it you can write this way: fx, x tends towards a upon gx, x tends towards a, provided that limit x tends towards a gx equal not 0. If you have already solved this type of the questions in the limit chapters, and you know, if fx x tends towards a limit and gx x tends towards a are simultaneously 0, then what happen? In case limit fx upon gx takes the form of zero upon 0. So what do you mean by 0 upon 0? It is indeterminate forms. It is indeterminate forms. So is fx upon gx x tends towards 0 is not exist. It may be exist, it will be exist. Then student, how we can solve this type of the questions? Evaluations of indeterminate forms, when we see we can see indeterminate form may be indeterminate forms are maybe 0 upon 0 type, or infinite upon infinite type, or 0 into infinite type, or infinite minus infinite type, 0 to power 0, 1 to the power infinite, and it may be infinite to the power 0 types. Okay, these all are indeterminate forms. Now all these indeterminate forms can be solved using this main forms 0 upon 0. Okay, now evaluations of this indeterminate forms, we can use two methods, one algebraic method and second is L'Hospital's rule. Evaluations of indeterminate forms. These evaluations of indeterminate forms can be done by two methods. Number one is algebraic method and number two is L'Hospital rule. In algebraic method we have already learned some series, some other formulas in the limit chapters. In these chapters we will use the L'Hospital's rules. Okay, so evaluations of indeterminate forms of 0, 0, we will start with L'Hospital's rules. Right, now the name of complete name of this mathematicians is Marquis Day L hospital. Okay, so this rule is given by this mathematician, so we can say Day L hospital's rules. Okay, now if we take the form 0 upon 0, then we are going to be describing about these forms. If fx and gx be two functions of x such that two functions of x such that condition number 1, limit x tends toward the fx equal to 0 equal to limit of gx x tends towards a, and second point should be both are continuous at x equal to a. At x equal to a, and third point should be both are differentiable at x equal to a. Okay, and now the fourth point is f dash x means differentiation of x and g dash x are continuous at x equal to a, then limit x tends towards a, fx upon gx equal to limit x tends towards a, f dash x upon g dash x, provided that g dash x equal not g dash a equal not 0. Okay, so student, meaning is this: when 0 upon 0 is given, you have to differentiate of numerators and differentiate of denominator and put the limit a. If it is 0 upon 0, then again you have to differentiate numerator and denominator. This process will be till then when it is you can find a particular values. Okay, so this point you should be understand: if limit x tends towards a, f dash x and g dash x also takes the indeterminate form 0 upon 0, and f dash x, g dash x satisfied all four conditions as given above. Okay, then we may again apply the rule on f dash x upon g dash x, x tends towards a, and we may get limit x tends towards a, fx upon gx equal to limit x tends towards a, f double dash x upon g double dash x. If again we arrive at the same conditions, if again we arrive the same indeterminate form, we may again apply the above rule unless we arrive at some conclusion. Student, this you can understand by some examples. Okay, then you can better understand. So we are doing the question of 0 upon 0 form. Now the question is limit x tends towards 0 sin x upon x. Now we can see if we put the 0 here directly, we are getting here 0 sin 0 is 0 and this is 0, it is 0 upon 0 form. This you have to calculate, putting the values of this always. Okay. So using L'Hospital's rules, we have to differentiate of this, finding f dash and finding of dash is. We can find differential of sin x is cos x and differential of x is 1 x is. So now putting x equal to 0, what we have done here, applying here L'Hospital's rule. L'Hospital's rule. Okay. Now if we put this 0, it is 0.0 form. So it is cos 0 upon 1. It is 1 upon 1. So your answer is, conclusion answer is 1. If it is again 0.0 form, then we use this rule again. We differentiate it again. Numerator differentiate and denominator differentiate. Then apply here values, limit. Okay. So student, you can do this type of the questions. Now one more questions I am doing this way. Log e base 1 plus x upon x, x tends towards 0. 1 plus 0 means log 1. Log 1 is 0. It is 0. So it is 0 upon 0. Using L'Hospital's rule, we can see differentiate of this log 1 plus x, that is 1 plus x upon 1. X tends towards 0. Now putting here, we get 1 plus 0 equal to 1. So it is your required solutions. Okay, student. Now do more questions here. Sin x minus x plus x cube upon 6 upon x cube. X tends towards 0. Now we can see, if we want to find the limit using L'Hospital's rule, putting the values of here sin 0 0, minus 0, 0 cube 0, and it is 0. So it is 0 upon 0 form. This you have to check. Hence using L'Hospital's rule, we can differentiate it. Cos x minus 1 plus 3x square upon 6 upon 3x square, x tends towards 0. Now if we check that, we put here 0, cos 0 1, 1 1 cancel, and 3 0, so total is 0, and here is also 0. It is again 0 upon 0 form, again using L'Hospital's rule. Again we have to differentiate of this. What we got it? Minus sin x minus 0 plus 1 by 2 into 2x upon 6x, x tends towards 0. Now putting the value of here again sin 0 0 0 0 and 6 into 0, again it is 0 upon 0 form. So again using L'Hospital rule, we can see we have to again differentiate of it. Minus sin x, that is differential is minus cos x, and plus 1, okay, upon it is 6 into 1, so x tends towards 0. Now putting here minus cos 0 1, minus 1 plus 1 upon 6, so we can getting the fresh value here 0 upon 6 equal to 0. Now it is defined, so it is your answer. Okay student, are you understanding the topic? Now one more question. Determine the values of a and b for which limit x tends towards 0, x 1 plus a cos x minus b sin x upon x cube equal to 1. We have to find the value of a and b. X 1 plus a cos x bracket minus b sin x upon x cube equal to 1. So now we can see, if we putting here 0 0, this total is 0 minus b into sin 0, and 0, so it is 0 upon 0 form. So using L'Hospital's rule, we have to derivative of this. So what we got, the derivative of this, that we use the product formula here. 1 plus a cos x in plus x, 0 plus minus a sin x minus b cos x upon 3x square, x tends towards 0, equal to, it is given answer is 1. Okay, now we are getting here 1 plus a cos x minus b minus x a sin x minus b cos x upon 3x square equal to 1, x tends towards 0. After simplification, we are getting this value. Now you can see here, as x tends towards 0, numerator of LHS tends to 1 plus a minus b. If you putting the value of 0, then we get 1 plus a cos 0 1, and here is minus cos 0 is 1 to minus b, and but here we are getting denominator is equal to 0. So we can say, using L'Hospital's rules, if it is this be 0 upon 0 form, so we can say 1 plus a minus b is equal to 0. Okay, so if it is 0 upon 0 form, we can say 1 minus a plus b equal to 0. Okay, now let it is first equation. Now again using L'Hospital rule, limit x tends towards 0 minus 2a sin x minus xa cos x plus b sin x upon 6x equal to 1. Now we can see, if we are going to be putting the value of 0 here, here 0, okay, this was 0, this is 0, 0 upon 0, so it is again upon 0. So again we are using the same method, and we finding it minus 2a differential of sin x is cos x, and using multiplication formula we get xa sin x, xa sin x plus and minus 1a cos x plus b cos x upon 6 into 1 equal to 1, and simplifying this, what we get, minus 3a cos x plus xa sin x plus b cos x upon 6 equal to 1. So now if we put here cos 0 1 sin 0 0, it is cos 0 1, so we get minus 3a plus b upon 6 equal to 1. Okay, hence minus 3a plus b upon 6 equal to 1. So we get the equation minus 3a plus b equal to 6, second equation. Now we can solve for a and b, first and second, and we can get the value of a and b. The first equation was 1 plus a minus b, and 1 plus a minus b equal to 0. So adding 1 plus 2, we can solve this. 1 plus a minus 3a equal to 6. So we get 1 minus 2a equal to 6, minus 5 equal to 2a, a equal to minus 5 by 2. And hence we can find the value of b, that is b equal to 1 plus a, 1 minus 5 by 2 equal to minus 3 by 2. Hence your required answer is a equal to minus 5 by 2 and b equal to minus 3 by 2. So using L'Hospital's rules, we can find the value of a, b and c this way. Okay student, so this is the best question for you. Now I am going to tell you the next point. Student, you have learned this L'Hospital's rules of indeterminate form, of 0 upon 0 form, and you have done some questions according to this. Right? Now in the next video I will tell you evaluations of indeterminate form of infinite upon infinite. Thank you for watching.